Hey guys, welcome back to AlgoYogi. We are doing tree series right now and only 3 more problems to basically go to complete this series. This is our last medium problem. Convert BST to greater tree. Let's go to the problem on LeetCode. And the description is, given the root of a binary tree, convert it to a greater tree. And what is greater tree? Which is such that every key means value of the original BST is changed to the original key plus sum of all the keys greater than that particular node's key. That's it. That's the this is basically the definition of the BST. We already know it. We don't have to go into this. So basically, left side of the root has all the values must be smaller. Right side must be greater. All are unique. And then we have basically, and that applies to all the subtrees. That's it. I just read you all the properties. Okay, let's go through our first example to understand what the problem is really asking us to do. These blue values you are seeing here, those are the updated values of our original tree, and that's what we need to do. Once we are done doing that, then we return the root as an answer. But what is this process that's going to convert our BST? This is a binary search tree to a greater tree. So if I look at 3, I see the updated value 33. And why it's 33? So as we have seen in the definition, greater tree would be adding this key 3 plus all the values that are greater than it, which is 4, 5, 6, 7, and 8. I'm not just writing them. They are coming from these tree. All the nodes that are greater than 3 and its own value itself. That adds up to 33. And that applies to all the nodes. That applies to all the nodes. So how are we going to solve it? Now, since it's a BST, we're going to utilize that property. And we're going to start traversing this tree from right sides because that's where all the bigger nodes are found. So if I look at the rightest node, the answer is itself. We don't need to update it since there is no other value. There is no other value that needs to be added to 8. So we're going to start traversing. We're going to do in order, but in the reverse way. So it's left, right, left, root, right. So it's going to be we process right, then we process root, and then we process left. All right, so that we processing the leftest node in the end, and we are basically combining all the values as we are going along the way. So we'll keep like a global variable to update itself, so that we are summing up all the values on our way when we are coming from right side, processing the root, and then coming to the left side. So when I'm here, I'm going to basically assign it all the combined values, and which will basically be its value also. So 8 plus all the values from right side. And then now I go back. So this is what I'm processing. I'll also process left side, but left is not there. Then let's forget about it. Then I will basically return my cur value, and I'm not even returning it. Honestly, I'm not even returning it. I'm just playing around with this global variable, and I'm just returning the control of our recursive function. Then we come over to its parent, and there we realize it has 7, and then we got 8 from below. So this current value is 8 right now. Then I combine and make it 15. This becomes 15, and my answer, I update my answer, and then I basically return back to the parent, and the same thing is going to happen. And then I process the right side, and right side would basically be I will update like this time this time this value also need to be added because root is supposed to be added. That's why this makes this approach really beautiful, because when I'm done processing right side and root, then I have this cumulative value that I just basically append to my left side and that key as well, and the answer is right there. Okay, so I think, all right, so let's code up our solution. And as I said, we're gonna have like a current total. So let's have it cur total values that will keep basically track of all the added value from when we are traversing from right root left, so that when we are at the root we can just update its value to itself plus the current total, total, and let's have it as array so that we can refer its value inside my inner function. All right, let us give some space over here, dfs, which is taking root, and base case basically, or it's a recursive, so we need a root is none, base case. If root is none, that means we return nothing, we just return the control, because this time we are basically traversing the array, just updating the values, nothing is being returned, and this guy is helping us do that. And then let's, since we already talked about this, we're gonna do the right side first, then we update the root value. So root value, root.val would be itself plus current total that came from right side, that's it, and current total will be basically itself and root.value. But now this is not same. It was supposed to be basically the value that was supposed to add it. So let's store it before changing its value into temp, and then just append the temp here to my current total. All right, and then that will simply return it, and we can run it on our root, run it on our root, and return the root. All right, since we are not like doing anything, so let's just return the root. Let me zoom out and see if it passes on our test cases. This is because it has to be at 0, right? And everything, oh my god, why I'm just doing this? I think that is because we didn't process left side. We just processed right and not the left. Okay, I'm just gonna directly submit it because I'm just so done with this problem. All right, that's it. Oh god, time complexity big of n, space complexity big of h, which could be equal to n. But anyway, let's mark this problem solved. We only have like 2 hard problems remaining, and let's fucking do it. All right, see you guys in the next problem. Bye bye.